to be started. Let's see, this is what I want to do. Oh, that's what we want to do. There we go. From current slide. Yeah, it doesn't have a white or a line or something, so Cameron came up with this. All right. I noticed they didn't take off the things in this classroom.
Yeah, and that was a whiteboard.
Yeah, but it could have been in pretty poor shape. I don't know.
They just missed it. I think they just missed something.
Yeah. Okay. Maybe there was a class in here the day they were doing it. All right, and what I'll do is hide presenter view and do why is this doing so strangely now? Let me go back from current slide. I thought I'd already done this.
Calculus fresh on your mind.
Oh, goodness. I've been doing it for 3 hours straight. No, 3.5 straight.
Is it a mini term or?
No. My calculus class plus the hour before class that
Dr. and Miss Martin's doing?
Miss Martin does.
Oh, okay.
Oh, so you did one of these already, Conley? Oh my gosh.
What?
That drive was a nice break.
Yeah.
Okay.
I'm wired. I was like, if I calculate the the instantaneous rate of change between the driver in front of me and the I see everything in calculus and physics.
Excellent. Okay. That's what I'm thinking. I don't know where that came from and why it's there, but I'm going to see if doing minimizing is fine. Okay, we got it. All right. Been recording 2 minutes and haven't gotten anything done yet. Okay. And let's get.
We always just start off with our friendly banter between one another and our aggravation against the system.
Okay. All right. What do y'all want to do? Do you want to do this calculus contest?
Sounds good.
Well, I mean, I want to scratch where y'all itch. I don't want to do something you're not interested in.
Is that the packet that she gave out?
Yeah, this is one of them. There were 2 that she gave out. One says calculus context and one contest 2008. The other says final exam math 8101 math functions, which I think is more pre-calculus.
Yeah, let's do
Calculus, that's what I thought. Okay. Now, do you want to just go down the list? Okay.
I haven't looked over.
I don't want to drag y'all down just
Right.
because I won't know anything.
Right.
With anything that we go over between now and the tournament,
Right.
please cater to Cameron because
Okay.
I can catch up.
Yeah.
I don't want him to,
Yeah. Well, this first one, both of you should have. This is the limit as x approaches 0 of the square root of x plus 1 minus 1. Now that minus 1 is outside the square root, okay, over x. Now, how do you approach a limit problem?
Well, first thing I want to do is plug in whatever.
Exactly. That's the first thing to do. Think Glade. Plug it in, okay? So, plug in x equals 0, and that gives you
0 to 1.
minus 1.
1 minus 1 is 0.
0.
Over
This
0.
is
So
0.
it's indeterminate.
Okay.
Or indeterminate.
Indeterminate form. Exactly. Now, if this had come out
Anything else
7 over 0, no limit. If it had come out 0 over 7, 0. That's it. You're done. Okay? Or 7 over 7, 1, or 4/3 or whatever.
Most of the time it's 0 over 0.
Yeah.
That's interesting.
Yeah. So if it comes out this, then you go from here. Now, if you do have this indeterminate form, what technique should you try?
Piecing it or factoring it out.
Okay. You could do that if you could,
And then
but
take a derivative.
yes, L'Hopital's rule. L'Hopital's rule, and that says take a derivative of numerator and denominator and see what that gives you. Now, when you're taking a derivative of the numerator, I like to rewrite that as x plus 1, right, well, to the 1/2 power minus 1. And what's the derivative of that?
That would be 1/2
1/2
times x plus 1.
x plus 1 to the
Negative.
-1/2. Okay?
That's the whole.
Okay? And then the derivative of minus 1 is what? What's the derivative of the denominator? 1. Okay? Now,
Is that minus 1/2 at the end?
yeah. When you're taking a derivative, y'all probably haven't gotten this far. Okay. When you're taking a derivative, it's exponent times your function, the thing, and then drop this by 1.
Okay.
Yeah, reduce by 1. So the 1/2, subtract 1, it becomes negative 1/2.
Okay, makes sense.
Okay.
You,
Yeah.
you know the derivative of like x squared.
Y'all are still in limits.
Yeah, we
Oh.
haven't got
They
it.
aren't even at derivatives yet.
Oh.
So that's why
This is
you're
good.
going to benefit the most out of
Yes.
anybody from this, because you're going to get all these
I'm
tricks
gonna
and
get a lot of
trades. Yeah, all right.
calculations.
Okay.
That's just the good old power rule.
Yeah, it's the power. When you have a power function, something raised to a power, that's what you use.
Yeah.
Okay. Now, so we now want to take the limit of this as x approaches 0. Okay? I know what the denominator is.
Yeah,
1. Okay? So whatever the numerator is. Let's rewrite this, go back to the 1/2, 1 over the square root of x plus 1. To me, that's easier to do the calculation from there. And when you go x approaches 0 there, what do you have? 1/2. Because this is 0 over 1. Yeah. So it's 1/2. That is one of your options here, B. And let's see, somewhere on the back here, they supposedly have some answers. And let's make sure they got it right. Yes, they did. Good for them.
So the limit y'all would do wouldn't have exponents in it more than likely.
What's that?
So the limits they're doing wouldn't be this involved yet.
We have exponents. We just haven't learned the derivative yet.
Right.
Like we.
Yeah,
typically
and
happens-
what you said to begin with, factoring, doing that kind of stuff,
And then
that's exactly what you,
trying to cancel out. And, yeah.
right.
Boy, I've gotten lazy.
Yes, exactly. Once you get
On
Yeah,
down the line, you
on
don't-
down the line, you learn new tricks that shorten the
We
whole
will
process.
teach you the tricks.
Yeah.
Because that's the whole key for this. It's not just to cheat you there, but it's because these things are timed, you know. So that's how we got it. So let's do number 2. The limit, another one of these, as x approaches infinity, of the square root of x squared plus 4 divided by x. All right.
So infinity over infinity.
Okay. And you can still do L'Hopital's rule with that.
Okay. So you set it up the same way?
Yeah. And what Cameron was saying, when you plug it in, this will be an infinitely large number, plus 4 is still an infinitely large number, square root of infinitely large numbers, infinitely large number, over infinitely large numbers. So infinity over infinity, L'Hopital's rule still works there.
It's about as relevant as 0 over 0.
Yeah, yeah. It's indeterminate. Okay? So what you do next?
Take the derivative of the top and the bottom.
Okay, so let's rewrite the top as x squared plus 4 to the 1/2 power. And of course over x. Okay? So let's take the derivative. I'm skipping some steps because you have to do all the steps in this, but okay? Derivative of that numerator. And again, do the same procedure we did before, but this has a little twist to it.
It's a chain rule.
Chain rule. And you'll get to that later this term too. Okay?
Holy.
But again, you do what you did before.
You
1/2
drag 1/2 out to the
Of this thing to the minus 1/2
Alright,
power.
so
1/2, I can't
it
write,
would be 2x.
of x squared plus 4 to the minus 1/2 power
But you multiply that 1/2 by 2x.
Right.
Or what would it be?
Do you remember in pre-cal, the, what do they call them? Decomposition of functions, okay? A function of a function.
Yeah.
Right.
Like,
Well, that's what you're doing here.
Yeah.
You took the derivative of the outer function, which was a power function, okay? That gave you this. Now you take the derivative of the inner function, which is 2x. 2x, okay? You 2 times x, drop that by 1. Yeah. So this is times 2x, okay? And
because this is stuff I already know.
yeah. Okay. Derivative of the denominator is
Just
1. Yeah, because it's 1 times 1, drop that by 1, x to the 0 is 1. What's that? That's a times there.
Oh, it's a time. I thought
Yeah.
it was a comma.
No.
I was like,
No.
okay, maybe I don't know this.
When I write on this, it flops back and forth in my periods. Okay, so now let's do let's do our limit again. Let's rewrite it. 1 over 2 times the square root of x squared plus 4. I put it in the denominator. That's what the minus 1/2, that moves it to the denominator.
Would that just end up being infinity?
Okay.
Oh,
And
no,
you still-
okay, so you're flipping it.
Yeah, well, because the minus 1/2 here means 1 over
I see.
1/2.
Okay.
Okay.
1/2 is the square root, and then a negative exponent.
Yeah.
We just move it to the denominator.
Okay. Now here the 2's go out because they've been dating. Okay. All right. And you have a 1 down here. Okay. Well, this form, guess what? Is still an infinity over an infinity.
Do it again.
Play it again, Sam. Okay. Except now it's not this denominator, it's this denominator, that fractional form.
Gotcha.
So, derivative of that numerator is 1. And that denominator, I'm going to rewrite it as
That's
x squared plus 4 to the 1/2 power, because I'm keeping it in the denominator. And its derivative, like we've just done, is,
Can we write that as, since it's being multiplied into it, could we just write that as x times x squared plus 4 to the negative 1/2?
right, yeah, if you can, because we just did it before, and that's what it came out being. You're absolutely right. When we did this derivative here, same one we're doing, it's in the denominator here, that's what you came out with, x over this thing. Okay? So here you have x over the square root of x squared plus 4. Okay? Been here before, haven't we? Almost going in circles here, aren't we? Okay?
What are you doing to us here?
Yeah. I don't think it's going to get any better, because then this is in the denominator, you flip right back over and you have it this way now. The square root of x squared plus 4 over x,
So,
because that's in the denominator.
is there an option where it does not exist?
Okay. Wait, okay. Here is the other thing you can do with ones like this. And I should have done this to begin with, but I thought, let's try L'Hopital's rule, see if it works. It just gets us in this vicious circle. So here's the other thing, especially if you're going to infinity. Can't really evaluate to infinity. So what you can do is multiply numerator and denominator by 1 over x. Over 1 over x. Now this, as x is going to infinity, that's approaching 0, but it never reaches 0, right? Get closer and closer and closer, but never gets there. So that's really 1. So it's a legal thing to do. Now, 1 over x is the same as 1 over the square root of x squared, right? So this would then be the square root of x squared plus 4 over the square root of x squared. This is all under the square root. And this is x over x. Okay?
That's one.
Which would be 1.
This is 1 down here, but that's what we kept winding up with here. And here, you see, what you get is the square root of 1
Yeah.
plus
Plus
4
4.
over x squared.
Right.
And as x approaches infinity,
You're getting really, really close to
this is going to 0. Square root of 1
is 1.
over 1. So it's just 1.
Okay.
So this answer should be, oh my goodness. Did I leave something off of the problem? Oh, I'm guessing it's none of these. I was going to say they don't have 1 as an answer, but let's see, they have 2 as E, none of these.
Oh, okay.
Okay, so sorry about that.
It is.
So L'Hopital's rule looked like it had promise until you saw it got in the loop. So actually, this is a better thing to do, but I thought this would be harder than L'Hopital's rule, so I thought,
That was
It
actually
wasn't.
really easy this time.
huh?
It's easier than doing L'Hopital's rule 3 times.
Yeah, oh, for sure. And especially when you saw it wasn't going to get you anywhere. Have you got a class coming up?
No, I think I left a clipboard in here.
A clipboard.
You can see a clipboard here. Well,
No? You could have been put in the back? Okay. All right, let's do number 3.
This one's for free.
Yes. D by dx of log base 2 of x squared plus 1.
I don't like these.
Okay.
Whine, complain.
Right. Okay. Now, without going through all of the, I can take you through how to do it analytically, but since you got your calculus book, there is a table in there,
Well,
and this would be worth remembering. I know you can't have them
yeah, you can't have it to
right,
probably.
you need a light on, or you'd rather have them on. Okay, and do here's the logarithm. Okay, and here we go. This one right here.
Okay.
Okay.
So it equals 1 over, it's like LN in parentheses.
Of
A.
yeah, of whatever your base is. Your base here is 2.
Okay.
Okay.
Close parentheses X.
Where is that?
Oh, excuse me. I'm sorry. The denominator is in parentheses,
Oh,
and then on the outside is X right there.
x. Okay, where x is your argument of your log.
It's 1 over natural log of A times X.
Okay, and what was x? The argument of the
I'm,
log base 2.
sorry.
Log base
So
A.
X squared plus
Yeah.
So this would be then x squared
plus 1.
plus 1. And that's in the denominator, right? Okay. But here you have a chain rule. So then you do times 2x. Because this is your inner function. So after you do the log of the outer function, call it y here. And then you do dy dx, which is 2x.
Okay. Now,
So,
can we do it analytically?
okay, we can do that.
Because I have a bad memory.
Okay?
I didn't.
All right. All right. There's several ways you can do this.
I don't like the log base 2 thing.
Right. Okay.
Log base 10 and natural log.
Yeah.
Natural log's the best.
Okay. Let me think of the probably. Let's call this something.
Let you equal.
Something like that. But this whole thing we're going to call y. That's okay to do, isn't it? Okay. Now, So y is equal to, and we're looking for dy dx, so remember that. Okay, so y is equal to log base 2 of x squared plus 1. Okay. Now, what I'm going to do is raise this to this, not to the e. I'm used to doing e, but this is the awkward part of, one of the awkward parts of this. How many steps? 2 to the this and 2 to the that.
Yeah.
Raising both of those to the second.
Log, you'd raise it to the e because that's the way,
Right,
because it's
exactly.
base e.
So this is 2 to the y is equal to raising a log of that same base, to this. Those are inverse functions of each other. So this just gives you x squared plus 1. Okay? All right. That's the trick to get you started. All right. And then at this point, I think I would be tempted to, no, because this is raised to the, now I think I'd raise it to the e. Okay? And what this will do,
E to the x squared plus 1 is pretty easy to do.
yeah.
Just taking the derivative.
Yeah. Well, I'm trying to think if this is the, I think this is probably the easiest. No, I'll take that back. Let's do a log of it.
Natural log?
A natural log of it. Or let's try it anyway. Okay. And the reason for that is one of our log rules. The natural log of this will then be the natural log of that. I just can't write very well. Let me clean that up a little bit. Okay. Okay. The natural log of that. Okay. Now, the reason I did that, notice that now we can do one of the principles of logarithms is this is now y times log 2. The log of a, this is a rule of logarithm. The log of a product is the sum of the logs. Okay? So if you have a log of y times y times y times y, that was log y plus log y plus log y plus log y. That's what logs do. They change a multiplication to an addition. They change the power to a multiplication, and that's what we just done here. Okay, so that's y times log 2. That's on the same line. That's not raised to an exponent there. And that's equal to log x squared plus 1. Okay? Now, divide both sides by log 2, which is just a number. Okay? So now we have y is equal to ln of x squared plus 1. I'm going to go, I started right over that, but I'm going to put 1 over log 2 because that's what it is, rather than put it in the denominator. It's just a fraction. It's just a number, okay? And now what we're going to take is dy dx, right? That's what we're looking for. So that is going to be, this is a constant, 1 over log 2, and the new one for you, derivative of a natural logarithm is 1 over the argument. 1 over x squared plus 1. And then chain rule 2x. It's the same thing we got using the table.
Okay.
What was it? You have a problem with it.
Alright, so you took the derivative of the natural log of x squared plus 1.
Right.
Gives you the 2x.
Because this is just a constant.
Yeah.
Yeah, so that's up front. Natural log of this is 1 over this. So that's what gave you that. And then you do the chain rule on
But you
this
keep
part.
the constant.
2x. Huh?
You keep the constant.
Yeah, that's multiplied by it. Yeah. If it were added plus log x, then the derivative of that is gone. Yeah.
And if, okay, so yeah.
That's the coefficient. Yeah.
And since it's not raised to any power, you don't multiply that by any.
Right. Exactly. Okay. So that's
Just making
how we
sure.
got the same thing. Okay.
And then you combine it and you get that.
Okay. So that was that was number 3, and let's see if they have the answer down here anywhere. Number D says 2x over x squared plus 1 times log 2. So it looks like D is the answer, and in the back, D is the answer. All right. Okay. Tell me when it's all right to erase. I don't want to get ahead of it. Good? Okay. All right. Number 4. D by dx of inverse tangent of 2x. All right. And I bet you want it analytically, don't you? It's okay if you do. Do you?
Yeah, I would. Yeah, analytically would be the way to go.
Okay. All right. Sort of the same trick as before. Let's call this thing y. So we're looking for dy dx again. So y is equal to inverse tangent of 2x. Now, what does an inverse function? Do you need to be in here?
No.
This is just a study session. It's not a class.
How long are you?
About 4:45, or do y'all need to leave earlier?
Okay, I'll come back.
Okay.
Okay.
Okay. Yeah. Okay. Do y'all remember what it means to be an inverse function? What?
It's the opposite of
One
the other.
Okay. So in other words, if you take a tangent of this side,
It would be the.
then you lose that. The inverse of a tangent of an inverse tangent, like, yeah. So that gives you this. Right.
Inverse tangent is cosine over sine, correct?
No,
Is
okay.
That's
Tangent is cosine over sine. Sine over
Yes,
cosine.
Okay.
Arctangent, yeah, same thing. Arctangent.
Inverse tangent, arctangent. Completely
Yeah.
different. And if you multiply an arctangent by a tangent, arctangent goes away.
Got it.
Yeah.
Oh,
Yeah. Any function of its inverse, like the square of the square root, you lose everything but what's inside. Okay. And the e of a log and log of e, the 2 of a log base 2, they undo each other. So this gives you a new equation here. Okay? Now, if I told you to take the derivative of both sides of this, what would that give you?
Well,
Do you remember what derivative of tangent is?
no.
No.
The sine and cosine are easier.
Okay, so we can do that.
We can-
So this is,
Wouldn't that just be the derivative of sine over cosine?
yeah, that's what we just said.
Yeah.
Sine of y over cosine of y is equal to 2x.
Or, well, we can probably go ahead and write that
What's that? Well, once we take the derivative, we will. Okay, and what's the derivative of sine y over cosine y?
too. It would be, that's a
Quotient rule, right?
High, low, high, low.
Yeah.
So,
If it sounds like he's starting to yodel, don't worry. Yeah, okay.
It's something he taught me.
Yeah.
So you take the low one, which is the cosine.
Yeah,
So
cosine.
Right, cosine y times the derivative of sine y, which would be negative cosine.
Now, derivative of sine is cosine.
Cosine. I always get that mixed up. Cosine of y.
Okay.
And then
Minus.
high the low.
Right.
would
So that'd be sine y
minus sine y. Or, well,
times a
se-
negative sine y.
Right.
Okay. And that's equal to, you've taken the derivative of this, on this side you got a 2. Right? Now, this is cosine squared y. Minus of minus is plus sine squared y. Oh, one thing we didn't do. Sorry about this, I almost forgot. When you took the derivative of the sine y, this gave you a y prime 2. Chain rule, same type thing. You take the derivative of sine y, that's cosine y, times derivative of y. And same thing here, this gives you y prime. Okay? So you have a y prime in each of that, but these, so this is what you have, and that y prime is dy dx, by the way, I'm just writing it shorthand, is equal to 2, right? So what is,
So y prime equals 2 cosine squared y plus sine squared y?
yeah, but that usually comes out being 1, isn't it? And this would say that y prime is equal to 2. That's not true. There's some little catch here I'm missing.
Can't really
Goodness
divide
gracious.
the cosine and sine over to the other side, can we?
Okay. Second.
We can't divide the cosine and sine over to the other side, can we?
That's what we'll do. Dy dx then
Equals
is equal to 2 over cosine squared y plus sine squared y. But if you remember that looks awfully much like 1, but it's not quite, because I think what we have to do is then put in what y is, and y is,
Oh man.
Do you want me to just tell you what the inverse trigonometric function is?
yeah,
And then you can just write it up top. It's d over dx
yeah, of that would be,
in parentheses tangent -1
right,
x equals
1 over
1 plus x squared.
exactly. Only our x here is 2x, so this will be 2x in parentheses squared, and then we'll have the derivative.
Two.
2. Yeah.
Okay, so
I was just showing you what
Yeah.
we needed to get to now.
Right. So this is the same as 2 over 1 plus 4x squared. That's what we need to get to.
yeah. And if you plug in what x is, shouldn't, well, no, because x is negative, inverse tangent of 2x, right?
Yeah. And I've already done that substitution in here.
Yeah, so 2x.
But where the problem comes is,
That wouldn't be an identity, would it?
it's sort of, it comes from an identity.
Okay.
Oh, wait.
It looks.
Oh, wait, here's where we messed up. All we did was high d low and low d high. We didn't do over denominator squared. Cosine squared y. Okay, derivative, and yeah, you wouldn't know this yet.
All over.
Yeah, all over cosine squared y. That's where we messed up. This does indeed go to 1, but you've got, sorry,
Over.
So that should be over cosine 2y.
yeah. So what we have here, this is 1, and this is 2 times cosine squared y. Okay. But that's a little inconvenient. Okay. In fact, what is 1 over cosine squared?
That would be sine squared.
No.
No.
1 over cosine squared.
Oh, that's a secant.
Secant squared. Okay. So this is the same as 2 over secant squared y. Right? Okay. Now, here we have tangent y. How is tangent y related to secant y? Anyone know?
Well, 1 over cosine is secant. And
What's that?
sine over cosine is tangent. So
Okay. Well,
that's what
okay.
we're talking about.
Yeah.
This is the denominator.
Here's what I'm fishing for. Our good old Pythagorean identity. Sine squared y plus cosine squared y is equal to 1. Right? Let's divide everything on both sides by cosine squared y. Cosine squared y. Cosine squared y.
So you get tangent y
Tangent
equals
squared y
y
plus 1
plus 1.
is equal to secant squared y.
Okay.
Okay? So what we wound up with here is 2 over secant squared y, but secant squared y that's the same as 2 over 1 plus tangent squared y.
Oh, goodness.
But what is tangent y?
2x.
2x. So this is 2 over 1 plus 2x squared. And this is 2 over 1 plus 4x squared. And that's what we got from there. That's what we got here. Let's see what we got here. 2 over 4x squared plus 1. That's the C answer here. And to see the answer in the back is 4. I'm sorry, it's the D answer. Yeah, is 2 over 4x squared plus 1. I was looking at 2x over 4x squared plus 1. It's 2 over 4x squared plus 1. That is the answer. And it is the answer in the back, D. Okay. All right. Let's go to, all right, to erase. Okay, number 5. If, I'll write it all out because y'all don't have your slings with you. 2x minus x squared is less than or equal to f of x, and that's less than or equal to x squared minus 2x plus 2.
Is the squeeze there?
I think so. It looks like it. For all x, then the limit as x approaches 1 of f of x is what?
Plug and chug. Right?
What's that?
Plug it in.
Yeah, plug it in. Plug it in here. Plug it in
And on
here.
that side.
If they happen to be the same, then that's got to be the limit of that.
Right. That's
Okay.
what it just went over.
So what's the limit as x approaches 1 of this?
That'd be 2 minus 1, so 1.
1. What's the limit as x approaches 1 of this?
1 minus 2
Oops.
is 1. 3.
Yeah, 1 minus 2 is?
3. Or 1 minus 2 is 1, plus 2 is 3.
Okay. 1 minus
2 is negative 1.
2 is negative 1,
Plus 2 is 1.
plus 2 is
Plus
1.
I see. I'm
Yeah.
sorry.
Right, okay.
I do.
Okay, yeah. So, sure enough, this had better be 1. Okay? And number 5 here says 1 is C. It's yes in Spanish. And that, sure enough, is 5 is C. C, it is.
I'm sorry. Do that.
Okay,
You want to do that one more time?
all right.
I don't know
This one
why.
over here.
Yeah.
1 squared is 1.
1 squared is 1.
Minus 2 times 1 is
Negative 2.
negative 2. 1 minus 2 is
Negative 1.
negative 1 plus 2 is,
Possible. Okay.
Okay.
I don't know why.
Yeah.
Okay.
Sorry. I think what
Yeah.
she did was she did 2 minus 1 instead of 1 minus 2.
Got it.
Got it. So as long as each side equals the same thing, squeeze theorem says.
Squeeze theorem says the thing in the middle does. Okay? I almost missed 6 here.
And that was what letter?
That was C.
C.
I think we have the answers on our packet.
It is.
Yeah.
Okay. Here's number 6. Another limit. The limit as x approaches -2 of x cubed plus 8 over x plus 2.
Alright.
0 over 0 is indeterminate.
What's that?
It's
It's
indeterminate.
indeterminate because this is x approaching -2. This is -8 plus 8 is 0 over 0. Now,
Okay, so this would be when we factor it
you
out.
can factor. Do you remember how to factor the sum of two perfect cubes?
Oh,
Isn't
man.
it X?
X
I gotta break out Pascal's triangle.
X plus 2.
plus 2. No, it won't work on Pascal's triangle. That would
no,
be
that's for-
x plus 2 cubed, not x cubed plus 2 cubed. So that's the first term. Okay? You got that right. Now for the second factor, I said term, but I meant factor. The second factor, forget about this. Use just this. Square the first,
X squared.
x squared. And then it's minus the product of these two.
Okay, so minus 2.
Minus 2x. And then square the last term,
Plus 4.
plus 4. Over x plus 2.
And that cancels.
Divides away.
It
And
reduces-
now you can do the derivative, the plugging in. And what would that give you?
It's 4.
4,
plus 4.
4 plus,
Plus 4.
which is
12.
12. Sure enough, that should be the answer. Oh my word. Is there another none of these?
I don't like it when they have those in there.
Yeah.
Kind of a cop out. But then again, I guess.
6, sure enough, is a
keep it
E.
away from
Now,
guessing,
Now, this is just about as easy to do L'Hopital's rule. Derivative of that numerator is
3x to the second.
3x squared, and the 8 goes to 0, over 1. Plug in a -2,
And you get 4 times 3, which is 12.
12.
Derivative.
So they both work.
That's
Okay.
very cool.
I don't like factoring.
Yeah.
When I don't have to.
What's the F word? Okay, never mind. Okay.
So
That's very convenient.
it's like I have to reassure everyone around me it's fact.
It's factor. You were in my 112 class, weren't you? Yeah, and did I ask that question in there? Yeah, I thought so. So he's familiar with it.
Same with goodness, side angle side.
Right. Oh, yeah.
No.
We-
Side angle.
Yeah.
We do side angle, but we don't do angle side.
Right.
Right, okay. Never mind. Okay.
I remember that one too.
All right.
It's from calculus.
Yeah.
It may have been trig.
It could have been. Probably was.
113.
Law of sines and law of cosines. Yeah. All right. To clear this? Okay. This one comes pretty close to stinking in my mind. Okay. It's a fairly derivative with respect to x of absolute value of x. I can tell you think it stinks too. Okay.
So that's
The
what,
expression
that's
only
what the derivative is whenever it's written like
When it's-
that.
d by dx,
It
yeah.
means take the
Well, there's
derivative
several
of
ways.
this.
Yeah. Yeah. You could also do f prime, that stands for the same thing.
Okay.
But d by dx, that's the derivative. That's
telling
one
you
way
to
to
take
say it.
the derivative of
Yeah.
whatever that is.
Okay.
You see dy dx.
Okay. What you need to do on this one is write down, let's call this f of x or something. Just it's a function. And what that is, or we could just leave it like this. Absolute value of x it's a piecewise defined function. It's x for all x's less than, greater than, yuck. Okay. Greater than or equal to 0. I have to come back and do this again.
Negative x.
Greater than or equal to 0, and it's minus x for all x is less than 0. Okay? That's what we mean absolute value of x, right? If positive numbers, absolute value of x is just x. And if it's a negative number, like negative 7, it would be the opposite of negative 7. So it would be minus x. Okay? For all x is less than 0. Okay? So now what we have to do is take the derivative of each of these. So d by dx of x is 1, and d by dx of minus x is negative 1. Okay? So that would be okay. So no, okay. It would be either 1 or negative 1. Now, so the A answer is 1. That can't be right. The C answer is 1 over absolute value of x. That won't work either. No. The D answer is 0. Couldn't be. The E answer is none of the above, but here's what B answer is. Absolute value of x divided by x. Okay?
That would work.
That would work because when x is positive, that would be x over x, and that would be 1. And when x is negative, that would be minus x over x, which would be minus 1. So sure enough, that is your answer.
The absolute value can't change the sign of the negative 1.
Right, exactly.
So, yeah.
Right.
Cool.
Okay. So that should be B. That's just that's a strange way to write it, but it is due, and that's number 7 is B. That's correct. That's not one I ever teach. This is the derivative of absolute value, but it just happens to be it. Okay.
I wonder, like, I'm sure they did something analytically to get directly to that.
I'm not as convinced as you are. I don't know, mate.
I don't know either, but
Yeah.
it just seems like they probably did something.
Yeah. I think it just winds up being that. Yeah. So I don't know.
Maybe in a table.
It could be. It could be. All right, to erase?
Yep.
Okay. Number 8. If y is equal to x over x plus 1, then, I'm shorthand here, the equation of the tangent at x equal negative 2 is equation of the tangent. That I think it should have line in there, but they don't. Okay, first thing you do when you want the equation of a tangent line, okay, here's what the equation of any line is: y minus y1 is equal to m times x minus x1. Right? That's called the point slope formula. Okay. Now, why did I choose that one rather than some other? Well, at x equal negative 2, that can be my x1, and you can plug that in here, and that gives you y1. Okay? So, you want to do that right now? y1 would be negative 2 over. Okay. Negative 1, which would be 2. So y1 would be 2 when x1. So y1 equal, what do we say, 2? Yeah. Okay. So we got those two parts. What we need is a slope. Now you haven't gotten here yet. This will be most advantageous to you. When you get to, this is just filling him in, why you're doing limits now, here's what a derivative is defined to be. It's the limit, if you have some function, of f of x plus h minus f of x over h, which I'm going to write a slightly different way for you. X plus h minus x. Of course, x minus x, that gives you just h. What is this? This is f is your y, and x is your x. This is change of y over change of x, which is your slope. So a derivative is the limit as h is approaching 0. It's your instantaneous change. It is the slope at the tangent line. So we need to do derivative of y. So here's another way to express that. Y prime, or dy dx, that means the same thing, is equal to, and this is a quotient rule. Hit it. Low is x plus 1 times the derivative of high, which is your numerator, is what? 1, minus high d low,
Which is 1x.
x, derivative of the denominator is 1. Okay? So, over x plus 1 squared, over the square of the denominator. That's the part we left off last time. All right, so this is, that numerator is x plus 1 times each of that, minus x. That is 1 over, notice the sound effects, okay, x plus 1 squared.
Okay.
All right, so that is your derivative anywhere except the x equal negative 1. Of course, that's not defined because x equal negative 1. It's not defined there. Okay. So, we're not worried about that. Specifically, at x equal negative 2, y prime at x equal negative 2 would be 1 over,
3 squared 9.
okay?
Or negative 2, dang it.
Yeah,
Negative, positive 1.
exactly.
Yeah.
So the slope is 1. Okay, slow down. Yeah, you're doing well, you're just going too fast. So the slope is 1. So m is 1. Okay, so now we can go back and plug in y minus 2 is equal to 1 times x minus a minus 2, which is plus 2, right? Okay, and that would be, add 2 to both sides. You can leave off those parentheses. Y is equal to x plus 4. There is your equation of the tangent line. They just say equation of the tangent. So y is equal to x plus 4. That on here is answer A. Let's see if they got it right in the back. And this is number 8. Yeah. 8 is A. Good for them. Good deal.
And you needed to get out of here at 4:45?
I need to leave at 5:15. I thought y'all needed to leave earlier. You need to leave
I
right
can
now?
say for one more.
One more?
Just brief.
Okay.
I may have to
Yeah,
leave.
it's 4:42 right now.
Okay. But I thought y'all said 4:45 earlier. Okay, number 9.
Number 9.
If x cubed minus xy plus y squared is equal to x plus 1. Now, I hope they wrote that right. That looks suspicious. Then y prime is what? All right. Now, we kind of sort of did something a little like this before. This is well into Cal 1, so you'll be hitting this by the end of the term. This is what we call implicit differentiation. You can't solve this equation here for y. If you could, then you just take the derivative of it. But you can't do it because this has a y squared, this has y with x multiplied by it. There's no way you can do that. So here's what we do. We differentiate implicitly term by term. What's the derivative of x cubed? 3x squared. Very good. Now, minus implicit differentiation. This is a product rule. Okay, now you haven't hit that yet. We've done quotients. We haven't done product. What a product rule says is the first times the derivative of the second plus the second times the derivative of the first. Okay?
As long as you take the derivative of one, multiply it by the other, and take the derivative of the other, multiply it
By one. Whichever order you want to. So which one you want to take the derivative of first? The x or the y?
We'll take x.
Okay. Derivative of x is
Y.
1 times y. And since a minus sign in front, we're going to keep the minus sign.
And then it'd be
X times derivative of y is y prime. See, y is a function of x. X is, is just x. Okay. So that's why we got a y prime. That's sort of a chain rule type thing, a little bit. Well, the next is especially that. Plus, what's the derivative of y squared? 2y times y prime, because of chain rule. Okay? We've done the left-hand side. The right-hand side, derivative of x is 1. Derivative of 1 is 0. Forget about it. Now, move all the terms leave all the terms with y prime on one side, all the terms without y prime on the other side. So we're going to subtract the 3x squared from both sides and add a y. You can just leave off the 1. I wrote it there for effect. Plus y. Okay? Now what we have, these go away. So you have I'm going to do a few steps at once now. Y prime times 2y minus x. I don't like leading off with the minus sign, so I switch terms. Okay, y prime times 2y minus x, right, is equal to 1 minus 3x squared plus y.
Does that mean that you can divide 2y minus x?
Now we'll divide both sides by 2y minus x. You are catching on very nicely. 2y minus x. That, folks, is your answer. Y prime or dy dx, however you want to say it. Those are both saying the same thing. It's equal to 1 minus 3x squared plus y over 2y minus x. And here again, you can't separate them. Okay? So let's see. That was number 9. And the B answers, no, that's not right. Okay, they tricked us. What they've done here is negate everything on both sides. So they went the other way. This could also be written as 3x squared minus 1 minus y over x minus 2y. None of their answers were this one. I bet you one of their answers is going to be that one. 3x squared minus y minus 1 over 2 minus 2, or x minus 2y. That's it, number C. Okay.
They negated it. We explained what you did. I'm sorry, I was looking.
Okay. The way we worked it out, it came this way. None of their answers are like this. But I noticed they had answers with a positive 3x squared. So I said, well, what if you pull out a minus sign here and a minus sign there? So that's what I did. That made this a minus, made that a plus, made this a minus. And this made this a minus and that a plus.
And basically what did that
So
was
they just multiplied by negative.
Negative 1 over negative 1. Right,
Yeah.
exactly.
Gotcha.
Yeah. What did you say?
well, it would have been negative 1. But I think they just instead of
What they did,
went the other way.
they went the other way. They moved this to this side and that to that side. And that would give it to them.
That's why it had different signs.
But
either
you-
way, you can still
Yeah.
multiply and it's
So we think that the answer is number C. Let's see if the answer is C. C. The answer is C. Okay. 9. That means no in German. 9 is C. No is yes, right. If you do European Union. Okay. All right. Y'all are strange people, you know. Okay. Was this okay? All right. We got through 9. So we can do the rest of them, Thursday? Approximately.
Thursday, or you want to do next Tuesday? You're doing like once a week or 2
I'm
times
planning
a
on
week?
coming every Tuesday, Thursday. Just
That's
like
fine with me.
Okay, So
Is
we're
that okay
gonna-
with you?
every
I know it
Tuesday,
eats
Thursday?
into your. If you need to do work study time, I'll leave stuff with you to
I
do
made
there.
an
Or
Excel spreadsheet specifically for all this. So it's all that. This is all the you said
extracurriculars.
the very sparse blank spaces.
Those are
That's
classes.
my free time.
Oh, free time. Okay.
Yeah. Ridiculous.
All right. So, folks, what I'm going to do is end the recording.